we're going to be going through the laws of exponents again, right? So these are all laws or rules or whatever you want to call them, but we need to remember them because as we are doing the calculations, we need to remember which ones to do when, right? Oh, excuse me. So we need to remember that if we have like bases being multiplied, we're going to keep our base and add our exponents. Now, I want you guys to be very, very careful here, okay? Because if I have 2 to the power of 3 times 3 to the power of 2, this does not give me 6 to the power of 4 just because the bases are not the same. That's not how maths works. Okay, we cannot do that, or 6 to the power of 5, in fact. Okay, we can't do that here. All right, 6 to the power of 5. It doesn't work that way. We need to make sure that the only two things we are multiplying together or adding the exponents of are bases that look exactly the same. All right, so we need to be very careful on what we're doing there. Likewise, if we have like bases being divided, we're going to keep the base and minus exponents. When we take a power of a power, wherever I see a bracket and an exponent, I'm going to keep my base and I'm going to multiply my exponents. M times n will give me mn. All right, now over here, if I have two different bases, I still have a bracket and an exponent. So each of the bases on the inside should get their own exponent. All right. Okay, this one is the same. Again, inside I have two different bases. Each of them should be multiplied with their own exponent. All right. Anything to the power of 0 is equal to 1. That's correct double distribution. And whenever we have a negative exponent, we cannot leave it with a negative exponent. So if it's sitting on its own, we're going to put it over 1. And then we're going to flip them. We're going to take that one to the top and bring this one to the bottom. Same as if I had 1 over a to the power of negative m. Because this thing at the bottom has a negative exponent, I still need to flip it. So I must take that one to the top to give it a positive exponent and bring the 1 to the bottom. So we can switch them around. All right, so we can do it going in both directions. It's not just the one direction. We can do it in both. So this will equal a to the power of positive m over 1. All right, my m looks a little skew here. Let's fix it a little. Okay, now I know that you guys have already done this, so I'm going to give you some time to practice. Can I give you guys some time to practice? I'm going to give you a couple sums, and you guys can try them and then put your favorite emoji in the chat when you're ready. I'm going to put that emoji. That's my emoji of the day because I'm so happy it's holidays, guys. Yo, hi. School is not for me no more. I'll see it again in April. I'm very tired. I want to go on holiday. All right, let's try these first 5 questions here. And when we've got the answer to those 5 questions, only once we've got the answer do we then put our favorite emoji in the chat. Okay, so try them. And when we're done, put your favorite emoji in the chat, please.
Ma? Any? Ma?
Tebogo, you're really fast. I think you're already done. We're just waiting on everyone else. Well done, my darling. We're going to give everyone else 1 more minute. All right, that's time. Let's have a look at some of these answers. All right. Okay, let's start with the first one over here. This one is quite nice and easy. I've got 2 squared times 2 to the power 4. Now, I'm going to note here that I have like bases. I've got a 2 there and a 2 there. When I have like bases being multiplied, I'm going to keep my base, and I'm going to add my exponents. 2 plus 4 will give us 2 to the power 6. And indeed, well done, Tebogo. 2 to the power 6 is actually 64. All right. Cool. All right. In this next one over here, again, I have like bases being divided. So I'm going to keep my base and I'm going to minus my exponent. So 4 minus 2 will give me 3 squared. And that is equal to 9. All right. 1 mark, 1 mark. Okay, now over here in question C, I want us to be very careful, guys. We need to note here that they're not actually multiplying. We are adding. We are adding. So I can't now say that my like bases are being multiplied, so I'm going to keep my base and add my exponents. I can't do that. Good, Deboha, that's it. I can't say that they're being multiplied. They're not. They're being added to each other. So we know that anything to the power of 0 is equal to 1. So 3 to the power of 0 is equal to 1 plus 3 to the power 4 is the same as 3 times 3 times 3 times 3, and that's going to give us 81. And therefore, our final answer, 1 plus 81 is 82. Right. In D, I can see here that we've got a bracket and an exponent. So I'm first going to keep my base. I'm not going to change my base. I'm going to keep it. And I'm going to multiply my 2 exponents. So that becomes 2 to the power 6, which is also 64. All right. In E, I'm going to note that my bases are not the same, but I still have a bracket and an exponent. So each of these numbers must get one of those. So I must go 2. By the way, when any number is sitting on its own, what is the exponent of any number sitting on its own, guys? If it doesn't have an exponent? Correct. Good. Sure, you're on fire. Excellent. If any number sits on its own, we automatically give it an exponent of 1. So both of these have 1. Now I'm going to get 2 times 1 and 2 times 1 there. So I'm going to keep my bases. So I'm going to write 2 to the power of 1 times 2 will give me 2 times 5 to the power of 2. 2 to the power of 2 is 4 times 5 to the power of 5 is 25. And that is equal to 100. That's the final answer we're looking for. All right, 1, 2, 3, 4, 5. Give me a number out of 5. How did we do? How much out of 5 did we get? Beautiful. Well done, Linomka. Well done, Teboho. Excellent, Wade. Okay, so this stuff is easy, right? I mean, we've done it before. There's nothing difficult here. I haven't really shown you guys something you haven't seen before. Tebogo, for which one? For the last one. Oh, okay. Let me guess what you did. You went 2 times 5 is equal to 10, and then you had 10 squared, and that gave you 100. Yes? Right. And you're not wrong, my darling. You're not at all. But remember what the question asked of us. Okay. The question said we must use the laws of exponents. So that's why I'm going in that direction, because the law of exponents shows me here that if I have two different bases inside the bracket, then I must distribute to each of them. Each of them must get their own bracket. I mean, their own exponent. Okay, so I'm using the instruction that I was given. Am I making sense? All right. Oh, I skipped one. Can we do this one quickly? Let's do that one quickly. Sorry, I should have showed you all 5, or all 6 of them. Okay, everybody's got 2 minutes to do this one over here. I feel like 2 minutes is stretching it. Maybe 1 minute. Yeah, 1 minute. Okay, we'll have a little bit of a look in just a bit, Ilham, and you'll explain to me. All right, but for now, let's quickly do F. All right. Okay, again, I see a bracket and an exponent. I know that the exponent of 7 is 1, so I'm going to distribute this 3 over here to each of those brackets. So what I should get here is 2 to the power of 6 times 7 to the power of 3. Right, now this is a huge number. Okay, and we know that with a number like this is what? If I write it out, I'm going to get 2 to the power of 6 is 64 times 7 cubed, which is 343. It's going to be really hard for us to find an actual number for this without using a calculator. So in questions like these, they wouldn't expect you to find the final answer. They would ask you to just leave the answer in exponential form. So there'd be no need for us to do the 64 times 343 part. We can just leave it over here. All right. All right, here's our next activity. The next activity says, which of the following are true? And correct any false statements. So if we find any of them are false, we should give the correction for each of them. All right. So let me see. Oh, there is an F. All right. I don't know if I can zoom out. Let me see if we can zoom out. Ooh, that's too much. Okay, there we go. All right, just give me a thumbs up in the chat, guys, if you can see all the questions clearly enough, because they are a little bit smaller, but I want you guys to see all 6 of them. Is that okay? Is it too small? Must I make it bigger? Oratile says okay. How does everybody else feel about the questions? Angel says okay as well. Ongumu says also okay. All right. Okay, the okays have it. Okay, so there are 6 questions. So I'm going to give you 6 minutes to answer these questions. And then when you're ready, pop your Ilham, that's going to be problematic. Okay, can I zoom in and then can you take a screenshot, my darling? Are you able to do that? Okay, great. Okay, I'm going to zoom in and then I'm going to show you the first three. Take a quick screenshot. Those of you who can see the questions, go ahead and do these three. And then the last three. Here we go, D, E, and F. All right, that being said, can I zoom back out? I'm going to zoom back out a little. Maybe let me see if I can make this thing full screen. Oh, not on the web version. I'm not going to be able to on the web version. Oh, excuse me. All right, guys, take it away. Musa and Ilham done with 1 minute to spare. Good going, guys. Oh, Wade as well. Good. All right, we'll wait for everybody else to catch up. Sure, Oratile, I don't know how you pulled that emoji off, but you need to show me. I want one. Definitely want one. That's pretty cool. Okay, all right, let's look at some of these answers over here. Let's start at A. All right, first one says here that 6 to the power of -1 is equal to -6. Is this wrong? Is this true or false? Let's start there. True or false, this one? What are we thinking, guys? Anybody got an idea? Yes, Ilham, it's false. Good. It's false because we know that the whole thing is not negative, just the exponent is negative. So what we need to do is put that over 1. So we need to get 6 to the power of -1 over 1. And then we're just going to take these two and we're going to swap them around. That one is going to go to the denominator and the one is going to come to the numerator. So the final answer we're looking for is 1 over 6 and not -6. All right. Now, let's look at this one over here. This one says 3x to the power of -2 is equal to 1 over 3x squared. True or false? True or false? Ilham says false. Is it false? Oratile says true. Is it true? Okay, I'm getting two differing answer. Angel says it's true. Interesting. Okay, let's go ahead and look at this in a little bit of a closer lens. Now, if I write 3x to the power of -2, right? We know that the exponent of x is -2. That's the exponent of x over here. What is the exponent of 3? What's the exponent of 3 here? What is the exponent of 3, guys? Of the 3 over here? It's just 1, right? Because any number sitting on its own gets an exponent of 1, right? Now, the rule says that we flip numbers or variables if they have a negative exponent. Now, if you look at this over here, the 3 doesn't have a negative exponent. Only the x squared part has the negative exponent. So even if we put this whole thing over 1 and we flip it, the only thing that's going to be flipped is the x to the power of -2. The 3 doesn't have to go anywhere. It has a positive exponent. So it's going to stay up top, and this is going to go to the bottom. Right, so well done, Ilham. You are on 100% correct, my darling. This is false. What's actually going to happen is we're going to have the 3 stay on top, and the x to the -2 will go to the bottom and become x squared. That's the answer we're looking for. All right. Now let's look at C. Bear in mind what Teacher Coco has just said about B. Let's look at C. Is C going to be true or false? What are we thinking? Ilham says false. Oratile says true. Think about what we've just done in question B. Angel says false. Okay, let's have a quick look. All right, I'm going to write it out. 3 to the power of -1 and x to the power of -2. Do you see how both of these things have negative exponents? So if we put them over 1, which one are we flipping? One of them or both of them? Which one must go to the denominator? Yes, Oratile, correct. Both must go to the denominator because they're both negative. So the 1 must come up, and the x squared must come down, and the 3 must also come down. So now that becomes 1 over 3 to the power of 1, x to the power of 2, which is indeed 3x squared. So this one over here is actually true. It's true. All right, so we must follow the exact same rules that we looked at when we were doing all the other questions as well. Okay, all right, let's look at D, E, and F. All right, now these things don't have any exponents. A and B don't have any exponents, so we know that we're going to give each of them an exponent of 1. So we see a bracket and an exponent, so we're going to multiply in. We're going to multiply in. So what we're going to get over here is a to the power of 1 times -2 will give me -2. And then b to the power of 1 times -2 will give me -2. Am I flipping one of them or both of them now? Because they're both negative. We're flipping both, right? They're both negative. So I'm going to put both of them over 1. And I'm going to switch them around. 1 comes to the top, and both of these go to the bottom. So my answer is going to end up 1 over a squared b squared, which looks exactly like the answer they've given us over here. So this one over here is true. All right. Ooh, E is kind of interesting. I like E. Okay, let me ask first before we continue. When we look at E, did we say true or did we say false? Tell me in the chat, did we say true or false? Ilham says false. What did everyone else say? Angel also said false. Okay. All right. I feel like everybody else was just like, ma'am, I was just gonna guess. Ashley says false. All right, let's see if this is actually true. Remember, this rule, the rule that we used in D, also applies in E. So I know that this 2 over here has an exponent of 1. And the 3 in the denominator also has an exponent of 1, right? Now that I see a bracket and an exponent, I'm going to distribute. Multiply, multiply, right? So I'm going to end up with 2 to the power of -2 over 3 to the power of -2. Now, that one has a negative exponent and that one has a negative exponent. So I must flip them both. This one must go to the top and that one must come to the bottom. Just like that, right? So now I'm going to get 3 to the power of 2 at the top over 2 to the power of 2. But now both of these share a power of 2. So what I can do is I can take out 2 as a common factor between them. And I can do that. Because that's basically the same as me saying that one and that one have a 1. And if I were to distribute like that, multiply, multiply, I would end up with this again. So this one is actually true. And it was supposed to be tricky. So don't feel bad if you're like, ma'am, I never would have seen, never would have seen that. It's okay. It was supposed to be tricky. This one over here is true. All right, let's look at F. What did we say for F? I hope we all managed to get F. F is quite easy. Did we say true or false for F? Ilham says true. What did everyone else say? Bongumusa also says true. Okay, Cool. All right, let's see how this question is going to go. Again, we're going to distribute. We know that 1 always has an exponent of 1. 3 has an exponent of 1. So we're going to distribute. I'm going to get 1 to the power of -1 over 3 to the power of -1. And now that they both have negative exponents, I can just flip them. Right? So on the top, I'm going to end up with 3 to the power of +1 over 1 to the power of +1. But as a matter of fact, 1 to the power of anything is just 1. So it won't really make a difference whether we write the power or not. And we also know that 3 to the power of 1 is just the same thing as 3. So 3 divided by 1 is going to give us 3. And that's the final answer. So this one over here, also true. All right, and those are the answers we're looking for. Give me a mark out of 6. How much did we get? 1, 2, 3, 4. And the first 2, 5, 6. What did we do? How did we do out of 6, guys? Let me know how we did. Well done, Ilham. Very nice. Angel got 5. That's okay. That's okay, as long as we know where we went kind of wrong in the questions. I know E was a bit of a tricky one. E was very, very tricky. Well done, Bongo Musa. Asanda got 4. That's okay. That's still a very good average. That's 80%. A little bit more, actually. Or is it a little less? Ooh, my math is not mathing right now. All right, let's get into a little bit more complicated things. But before we do that, I just want to check if Teacher Cat has left you guys a brain break, because I don't want to assume she didn't leave you guys a brain break. There it is. All right, let's do a little bit of a brain break and then we'll come back to the other questions. All right, it says here, would you rather carry a flip phone or use a desktop computer? Ilham, 6 out of 6 is 100%. It's 100%. So you got 100% for that last one. Well done. All right. Would you rather carry a flip phone or only use a desktop computer? I already know my answer. I won't even lie. Ooh, Angel, flip phone. Oh, I can't. I can't. I'm gonna find guys, I'm gonna find a loophole in this one. I would rather not use a flip phone. To be completely honest, I'm gonna look for, yes, me too, Linomta. I'm not gonna lie. I'm in my mind when they say desktop computer, I'm imagining one of those fancy ones from Apple with the 3 screens, you know, and the clicky buttons and everything. Yeah, that one I'll take. I don't know about that old looking computer. No, I want a brand new one from the Apple store. Then I'll take a desktop computer over a flip phone. But if it's like one of those old ones, like the first computer ever made, then now I'll take the flip phone. It's fine. I'll take the flip phone. I want to pick properly. I know, but I can't. Flip phone, nah. What? Oh, okay. No, wait. Okay, I'm changing my answer. Wait. No, if it's the Samsung flip phone one, yes. Look, guys, wait. I thought, am I revealing my age? I think I'm revealing my age because I'm very old. Guys, please ask your mom and dad what a flip phone, when we think flip phone, what we're actually thinking about. In fact, let me see if I can find you guys a picture of what a Nokia flip phone used to look like when we were growing up. Guys, don't laugh. Let me show you guys a picture. So this is what a Nokia flip phone used to look like. That is what I was thinking when you guys said flip phone. When you say flip phone. So I grew up using this. Guys, look at the buttons. Look at the buttons here. If I wanted to type the letter F, I would have to click the number 3 times. I'd have to go 333 to get F. And then if I want to click Z, I need to click the number 9 4 times. So I need to go 9999, and then it would go to F. Guys, we used to suffer. We used to suffer. So when they said flip phone, this is what I was thinking, not the new nice Samsung ones with all the nice digital screens. This is what I was imagining. Okay, okay, let's look at the next question because yeah, I want to see what you guys are going to say. Okay, we did that one. What about this one? Would you rather only charge your phone once a week or not have a camera on your phone? I choose 0 options. I choose no option. I don't choose an option. I'm sorry, guys. First of all, how do you go to sleep without charging your phone? Number one, right? And second of all, how do you go a single day without taking a picture? Way. Oh, wow, now you're walking around with this big thing around your neck every day because you want to take photos. No, this one is a skip for me. I feel like no, I can't do it. I can't do any of them. I refuse. I can't do any of it. I would I next question, no comment. Ashley, how? Ashley, how? I don't know how you would do it because I can't do it. A small camera. I want to see what a small camera looks like. And it's not even just that, Ashley. Like I also take pictures for work, and now I have to like write things down and email them to myself. No, I can't. Yeah. Mm-mm. I use my phone for too many things. Maybe it's an addiction. I don't know. Now I feel like I'm an addict. Ah. Oh no. Ah, okay, it's fine. But me, I say neither. Uh, oh my gosh, guys, this question. Okay, let's look at question number 3. Would you rather have to listen to only Justin Bieber or only Ariana Grande for the rest of your life? I have my choice. Me too. Ilham, every day of the week. I'm sorry, I love her voice. She's really, really cool. I like her music. Justin Bieber, on the other hand, I'm not sure. Sometimes, yeah, it's a no from Justin Bieber for me. I can't do Justin Bieber. Yo, no. Justin Bieber, no, guys. Nah, I can't do it. For the rest of my life, even. Imagine being an old granny with grandchildren, and every time your grandkids come into your house, you're listening to Justin Bieber, guys. What are your grandchildren gonna think? Like, how are you gonna explain Justin Bieber to your kids? Mm-mm. Yeah, I would rather listen to Ariana Grande. I can't do it. Okay. Okay, that was really fun. Okay, let's look at a little bit more complicated questions in terms of the maths that we're doing. So we're gonna up the game a little bit. We're gonna up the ante. Let's do this question over here first, and then we'll get to the others. All right, I'm gonna give you guys 2 minutes to answer this question on the screen. Remember, we're doing the exact same thing we were doing before. All right, take it away, guys. 2 minutes. All right, peeps, let's have a quick chat. Okay, now remember, guys, the rules that we're using here for maths for exponents don't actually change. We just need to keep asking ourselves, what do I see? What is actually happening as we're going along? Because this question isn't actually difficult. It just looks difficult, but we're actually working with the same base everywhere. If you look at the question very closely, there's a base of 3, a base of 3, a base of 3, and a base of 3. So everywhere we already have the same bases. So this is actually quite a simple question if we think about where the answer is going to go. So first thing we're going to do is we're going to get rid of the brackets. We're first going to take that 5 and we're going to distribute it into each of these. And we're going to take that 3 at the bottom and we're going to distribute it in. So what we're going to end up with on the top is 3 to the power of 20 times 3 to the power of 35 over 3 to the power of 6 times 3 to the power of 9. Now I can ask myself again, what do I see? What am I looking at? Well, if I look really closely, I'm going to see two like bases being multiplied. My two like bases are being multiplied. So at the top, I'm going to keep my base and I'm going to add my exponents. So this is going to give me 3 to the power of 20 plus 35 will give me 55. And same thing at the bottom. At the bottom, I see 3 to the power of 6 times 3 to the power of 9. Those two things have the same base and they're being multiplied. So I'm going to keep my base and I'm going to add my exponents. 6 plus 9 will give me 3 to the power of 15. And now I can see that my like bases are being divided and my bases are the same. I'm going to keep my base and I'm going to minus the exponents. 55 minus 15 will give me 3 to the power of 40. And we don't really have to go any further than that because 3 to the power of 40 is too big a number. It's no point. There's no point in us putting it into our calculator. All right. So what we're doing here is just we're following the same rules, even if it looks complicated. It's exactly the same, guys. We're not going to change any of the rules. All right. Okay, here's the next one. The next one is a real doozy. Oof. Look at that. But start with what we know. Let's get rid of brackets first. You've got 2 minutes, guys. Take it away. Start by getting rid of the brackets. All right, folks, if we're not done, I'm just watching the clock. I don't want us to run out of time. So let's have a look at this question really quickly. Okay, first thing we're going to note, we want to get rid of the brackets. So everything else can stay the same. 15 will stay the same, but in the brackets, we're going to distribute. And we're going to get 15 times a to the power of 2 times 3 will give me 6 times a to the power of 2 times 5 is equal to 10. Guys, note that I'm using a dot, and a dot in maths also means times. So you are allowed to use a dot instead of the times symbol. Dot also means times. Okay, and then times that b to the power of 5 that's hanging on to the end over there, right? Over 5 is there, and over here I'm going to multiply this 2 into the brackets. So I'm going to have 5 times a to the power of 14 times b to the power of 6. Okay, at the top I see two like bases being multiplied. I see an a and an a there, they're being multiplied, so I'm going to keep the base and add the exponents there. So I'm going to end up with 15. A to the power of 6 plus 10 will give me 16 times b to the power of 5 over 5, a to the power of 14, b to the power of 6. All right, so now I can see that things are being divided by each other. So 15 divided by 5 is going to give us 3. That part over there, 15 divided by 5 gives us 3. Over here, I see like bases being divided. I'm going to keep my base a, and I'm going to minus exponent. 16 minus 14 will give us 2. And then b, over here, I'm going to get 5 minus 6. That will give me negative 1. However, this little guy over here has a negative exponent. So this one needs to go in the denominator. I need to create a fraction for this and take that into the denominator. Do I have to take the 3 also to the denominator? I also need to take the 3. Yes or no? No, there's no need for me to take the 3. No, not at all, wait, because it doesn't have a negative exponent. So we're going to leave it there as well as the a squared. So we're going to get 3a squared over b to the power of 1, which is just the same as b. All right. Okay. Okay, let's look at this one over here. This one is an exponential equation. And honestly, I don't think this is for your class. This is a little bit too difficult. This is grade 10 work. So I'm not sure about that one. Okay, let's do these. These look a little bit easier. All right, let's do question 1 and question 2. All right, again, 2 minutes because they're very, very easy. So take it away, guys. Guys, did I just have that whole conversation with myself? Oh my word. We'll just pretend that you all could hear me and that, okay, so when the editors of the videos ask, you guys are just gonna say, no, we heard the whole thing. It's your side, it's the video. The video was the problem. Okay. So you guys have to help me because I completely forgot that I was muted. I'm so sorry, guys. Okay. Okay, but please check your answers against my answers. I'm sorry, guys. I'm sorry. I thought I unmuted myself, but off I went. I'm sorry. Please check your two answers with mine, x cubed, and the bottom one is 3y cubed. And then I'm going to give you one last question because it's actually quiz night. I'm not 100% sure where Teacher Cat has put your guys' quiz, but we'll find it. Okay, maybe if we want, we can take a screenshot of these two questions. We're going to do number 3 quickly, and then you guys can try number 4 before you run off and do the quiz. Before we continue, who can tell me what do brackets mean in maths? What do brackets mean? Who knows? Yes, absolutely, Ashley and Linomta. Brackets mean multiply. So if we look at what's happening at the bottom there, okay, that should tell you a story. All right, and it's officially 6 o'clock, guys. Sure. So let's quickly have a look at this question because I need to let you guys go. All right, there's nothing for us to do at the top because there's no operation happening yet at the top. What we need to do is figure out what's happening at the bottom. So I'm going to leave the top exactly the way it is. A to the power of 6, b to the power of 9 over at the bottom. I see two like bases, a squared and a, being multiplied. So I'm going to keep my base a, and I'm going to add my exponents. 2 plus 1 will give me a cubed. And same with b. b that has an exponent of 1. My like bases are being multiplied. So I'm going to keep my base and add my exponents. That becomes b to the power of 4. And now I can see the difference between the top and the bottom. Like bases are being divided, so I'm going to keep my base a and subtract exponents. 6 minus 3 is 3. B to the power of 9 minus 4 is 5. And that's my final answer. There we go.